we go. Everyone's coming in. Morning, good afternoon, good evening, everyone. Just gonna give this a minute to allow people in. This meeting is it's being recorded and transcribed as well. I'll explain more about that in a minute. Okay, let's get going. Okay, so hello everyone, good morning, afternoon, good evening, and welcome to our latest webinar on smart hydraulic maintenance. My name is Sam. I'm the Marketing Communications Manager here at WebTech, if you've not met me before. Today we have Martin and Steve both presenting for us, and I will hand over to them in a minute. I just wanted to go through a couple of little housekeeping for you. If you can stay muted, please. I think you should all be automatically muted, but if not, if you could mute during the session, that would be helpful for us. Any questions, by all means, put them in the chat, and we'll either come to them at the end, or you can ask at the end as well if you would like. So please do that. The other thing I was just going to show you, Martin, if you could just change the slide, please, is I think this live captions and translations will work on this session. So if English isn't your first language and you would like to turn on live captions and then have those captions translated into the language of your choosing, then you can follow the steps. If you're going to the more at the top and choose show live captions, that should bring you up a pane at the bottom of your screen where it will show you live captions. There is a setting at the top right of that little panel. If you click into there, you will see a language settings tab. If it's enabled, which I hope it is, you should be able to turn on translation as in that screenshot, and then pick the language. So give that a go. If it might be helpful, if you'd like to try. It'd be interesting to know if it does work. So maybe if someone could put in the chat if it does work, that would be great. And I think that's everything from me. I'll come back at the end to tell you what I'm going to send out afterwards. And I think we can hand over. One thing that would be nice actually is we try, if you have a second, just stick in the chat where you're from. What country you're from. It's always nice to see where people are joining from. We recognise names, but there are people we don't, and it's always nice to see where you're coming from. On that, I will now finish up and hand over to you, Martin.
Okay, thank you very much, Sam. Welcome, everybody. Thank you for sparing the time to join our webinar today. We do appreciate you taking your time out of your day to do that. My name's Martin. I'm also joined by Steve today, and we're both based at WebTech's manufacturing facility in the UK. And it's great to see so many of you from all around the world. So today's presentation, smarter hydraulic maintenance. So we're going to do this presentation in 3 parts. The first part will be background. So we'll talk about what do we mean by maintenance, a bit about background to data logging, because it maybe means different things to different people. And then we'll touch on really the cost of downtime. So that will be the first section, bit of setting the scene, if you like. And then we'll go into the second section where we will look at 5 different use cases and 5 different data logging products that WebTech has in its range, and really how they can benefit people. And hopefully you can relate to those different scenarios. And then the third and last section of the webinar, I'll hand over to Steve, and we'll go over to the WebTech website, and we'll just show you where you can get further information on the different products which are available. Hopefully that makes sense. So we're expecting the presentation, the webinar, to take around about 45 minutes. It may take a bit longer. I'm very happy to have questions, as Sam mentioned, so feel free to put them in the chat, and then someone in the WebTech team will flag them up to me as we go along, and we'll try and answer them if we can during the presentation. If not, we'll pick them up at the end. So for those of you who don't know WebTech, we're manufacturers of hydraulic measurement and control products. We have offices in the UK, in the USA, and in Germany. And our vision is to improve the performance of hydraulic machinery worldwide. And so while we will be featuring WebTech's products today, the focus is on education, and the principles that we're talking about apply to many data loggers on the market. And at the end, as I mentioned before, we will show you how to find out more about WebTech's products, how to contact our distributors, how to get a quote or technical information. And the last point, most of the information we're going to show you today are photos of our products or illustrations that we've made of our products. But we've also been trying out AI, as you can see by the image on the screen here. And so there are a couple of images during the presentation which are AI generated. And for transparency, we've labeled those, as you can see with this one here, that they are AI generated images. Okay, so let's move on then. Let's go to the first section, and we'll talk about maintenance types. And so for some of you who have been to our presentations in the past, you may recognize this particular slide. I think it's still useful to go around it, just to talk about some of the language which we use around maintenance. And so many of us will have experience of this particular machine that's on the screen now, or one that's similar looking to this. And we know that components on the car will need changing at different stages of its life, and some of those components, for example, changing wiper blades or replacing light bulbs, may be things that you only replace once they're broken, once they've gone wrong. And if you were to do that, then you may not realize it, but you're actually carrying out reactive maintenance. And then there may be other components on the car where your dealer may tell you, right, now's the time to bring your car in because you need to perhaps replace the cam belt or change the oil filter, and you perhaps groan and go, oh, yeah, that's going to be expensive, I've got to get that done. But you know that if you get that done, that preventive maintenance is going to save you a lot of money in the long run, because if that cam belt broke, you're probably going to write off the whole engine. So the cam belt cost is quite small compared to the damage that it could cause. And so that's an example of another type of maintenance, preventive maintenance. And then on many cars these days, you'll have sensors built in which will monitor brake pad wear and tire pressure. And that continuous monitoring of the air in those tires is an example of predictive maintenance. And that is that you can see in real time what's happening. If that air pressure goes down, it's a sign that you need to go and pump your tires back up. And last but not least, you may carry a spare wheel or use a run flat tire on a car, and that's really you being prepared for what might happen in the future. It hasn't happened yet. It might never happen, but chances are that if you hit that pothole really hard and you blow a tire, you'll be very glad that you're carrying a spare wheel or a run flat tire, and that would be an example of proactive maintenance. So hopefully that little illustration gives a sense of the 4 different types of maintenance that are available to you as a service engineer in a hydraulics environment. So if we were just to summarize those, we've got reactive maintenance, wait for it to go wrong and then fix it. And I suspect that, also called troubleshooting or fault finding, is what many people will think of when they first think about maintenance. Second type, preventive, estimate when it will go wrong and fix it before it does. Often requires that you test things on a regular basis and maybe compare data. The third one, predictive, monitor its condition in real time and then fix it when necessary. Requires that you actually mount sensors onto a system, onto a hydraulic system for a period of time or permanently. And the last one, proactive, try to stop it going wrong or minimize the consequences of failure. This could be during a site inspection test or a pre-dispatch inspection or a commissioning of a new attachment or of a new vehicle before it's used for the first time. And that would also be a sign of proactive maintenance. So the good news is, from the point of view of data loggers can help you with all 4 different maintenance types, whether it's reactive, preventive, predictive, or proactive. And if we look at what we're trying to prevent here, for many people, breakdowns are what we're trying to prevent. And breakdowns mean downtime on a machine. So if we take this particular example here, we've got a crushing machine. It's out of service. You see the red light blinking there, telling us that really it's not working correctly. Something's gone wrong. So we call up a service engineer. It might take 4 hours for someone to come out. This service engineer is obviously kitted out with all the latest data logging kit, because they diagnose the fault in just 1 hour. They then order a new pump. The pump delivery takes about half a day. They fit and adjust the pump, takes another 3 hours. They then have to flush the system, another 4 hours, recommission it, clean it up. In total, the machine's out of service for 26 hours. And in that particular industry, that quarrying industry, downtime costs about £2,600. So probably, whatever that is, $3,500, $4,000 an hour. So the total cost, when you add it all up with all the parts, it's coming on for $100,000, £75,000. So that in itself is a big cost for a machine being out of service. And if you look globally in the world, and here's an extract from an article saying that there's 3.3 million hours a year lost to unplanned downtime. So that's the big bogeyman, if you like, that we're trying to defend against, is stopping the machines breaking down. What can we do, and how can we use those 4 different maintenance types to prevent that? And the tool that we want to look at then is data loggers. But where are we today? So if you were to look today, for some people, your day-to-day quite often going to start with a pressure gauge. So for most of us who've been in the hydraulics industry for a long time, that's what we see everywhere on hydraulic systems, is a glycerine Borden type pressure gauge, and that will indeed tell us the pressure in the system. If we're not quite sure about the number, we might tap the front of it just to make sure that it's not sticking, but that's the kind of go-to device when people talk about pressure. If you're also monitoring the flow on a system, there's an example of WebTech's flow indicator. It's just an all mechanical flow indicator. They come in different shapes and sizes. That one also shows temperature. You could screw a pressure gauge into the top of it and get flow pressure and temperature. A great, reliable visual indicator of what's happening on your circuit. Now, if you went a step up from that and you looked at a portable hydraulic tester, so this model here is the WebTech RFIK. You might be using it as a pump tester, all mechanical, just to test whether the pump is performing when unloaded and when loaded. If you went a step up from there, this is could be a 100-gallon or 200-gallon, so 400 or 800-litre version for larger machinery. Again, you're testing flow, pressure, and temperature. You can restrict the flow, you can raise the pressure, and you can see all the values on the screen. So that's where many companies are, and they're great tools, and they allow you to measure, they allow you to test, and they allow you to view what's happening in your circuit. So what do data loggers do for you? Well, they take you a step further. So when we brainstormed the advantages of data logging over what I've just shown you in terms of just viewing data, we came up with 8 things. And here are the first 4. So you've got the advantage of continuous unattended monitoring. So if you want to carry out a test and you don't have a data logger, you've physically got to be there to carry that out. So the first example there, you could connect the data logger to a sensor and leave it there 24/7, and it will just monitor the system and then capture data when required. And that moves you neatly onto the second advantage, is you can automatically data capture. So you could put triggers on there or alarms that then start data logging when it sees something happen. And that gives you the opportunity to see fast transient spikes, so little pressure spikes going on in the circuit, which may be invisible to you. And when you plot that data, you can then see that very clearly graphically. The fourth example there on the right is around data integrity and accuracy. If you're writing down information, it may come down to your handwriting. Is that a 1 or is that a 7? It may come down to has that data all been recorded at the same time? So there's a couple of examples that I think we'll send you later on, some case studies of customers who have admitted the catalyst for them to buy a data logger was the moment they realized they needed to measure 4 or 5 different things in the circuit at the same time, and they needed a few different guys to be looking at different handheld glycerine gauges or flow meters in order to see what was happening at the same time. And then they're all trying to write down their own notes, and they're not entirely sure whether they saw them at the same moment or a few seconds different. So having a data logger allows you to pull information in and store it without any loss of quality, so it's same accuracy, and there's no chance that someone saw a number and thought, I don't like that number, I'll write down a slightly different one. What you see is what you get. So the next four areas which differentiate a data logger from just a viewing device, you've got traceability. So from the point of view of preventive maintenance, if you carry out a test today and you want to compare the test results with what you saw maybe 6 months ago, well, you can just go back and look at the data that you recorded 6 months ago. You could overlay those graphs and compare the two. Data visualization and insight, so you can drill down, you can capture it, you can draw it visually, and then you can drill down and look at any resolution you want. If you recorded it 1,000 times a second, well, then you could look at every millisecond of data, or you could zoom out and look at the picture over a whole day. The other thing is that for many customers, what's really important is being able to share information between departments. And we'll touch on that in the next section, or maybe between countries, at different divisions, or maybe it's around warranty and the machine's being used in a particular location, but in order to prove warranty and to get money back for warranty, you have to record a set of data and send that data back to head office. So that data sharing is really helped by the ability to data log it in the first place. And that ties really into the last point there around comparison and diagnostics. So it could be that the data is put up on a big screen and you maybe have some alarms or compare that data to what the manufacturer's data is. So they're just in brief, so 8 differences and advantages of data logging. So when WebTech talks about data logging, we talk about these 5 products. And these are the 5 products which we're going to expand on a bit more in section 2. And if we had to come up with one sentence, if you like, explaining what is data logging, we're saying it records and saves different machine measurements over time, helping you monitor performance and quickly find problems. And these devices here, they vary in size, as you can see, from left to right, in complexity, in the number of channels, and we'll touch a bit on that as we get into the next section. But we would class them all as being forms of data logger. And when we talk about data logging, what information are we recording? Well, in the hydraulics industry, we're pretty much always talking about those top 3. We're pretty much always talking about flow, pressure, and temperature. And then very often, the pump is being driven by a diesel engine or electric motor, and we want to know what speed that's going around at. So we might well measure the input speed, and so measuring shaft speed is very useful. We know that downtime in hydraulics is often linked to contamination and to oil quality. So monitoring the contamination or relative humidity is often another piece of information, particularly on test stands and the like, where that also really useful to pull that into the data logger. And then in that last section, that bottom right-hand box there, you can see that we've got a whole list of different inputs there. So whether it's frequency, milliamp, amp from like a solenoid, voltage or CAN, and J1939 is kind of the mobile protocol often used of CAN. It could be that you already have an existing pressure transducer or a linear transducer or a torque meter. So any of those things can then be fed in using custom inputs and auxiliary inputs into data loggers. Now, if that's a requirement, then that's something you need to flag early on because some data loggers allow you to do that and some of them don't. Okay, so if we go back to those 5 data loggers that we showed briefly beforehand, and I'm not going to go through every cross on the chart there, but when we talk about data logging, we might think that data logging is this one thing. Do you do data logging or don't do data logging? And really, as you can see across those products there are 7 different types. Down the left-hand side, we've got 7 different measurement types of data logging, and we'd class all those measurement types as the family of data logging. And as you can see by that example across the top, you can see there's an X just under each of those products, and in the row that says start, stop. And that's really the simplest form of data logging, where you literally, like an old-fashioned tape recorder, you press start, it will just record everything against time until you press stop, and then you've got one record, one test, and you'd save that test. And perhaps you can choose how quickly, so what the sample rate is, whether that sample rate is 1 millisecond or 10 milliseconds or 100 milliseconds. But that's the sort of most basic, simplest form of data logging, which, as you can see, is available in 4 of the 5 different devices on the screen there. And then as you come down that list of measurement types, there are other features that get introduced. So the data logger, as it's called there, is really being able to define how long that test is going to last, when's it going to start, when's it going to stop, rather than just pressing start and pressing stop on the keypad. And then if you look under the HPM 7000, everything's crossed. It's got all of these different features. It's the most powerful data logger that WebTech makes. And you've got all these other features like trigger and trigger logic. And some of those we'll touch on in the next use cases. But that's where, rather than you pressing the button, you can actually look at the values of the signals coming in and say, well, if this signal is greater than this value, then start data logging. And they're enormously powerful for when you're looking for an intermittent fault, for example. You don't know when it's going to happen, but you know what the characteristics are. You know that it's likely to result in a pressure spike or a reduction in flow, and you can trigger on those things. We've also got their fast measurement. As I mentioned before, you can record at different sample rates. For the devices that you can see on the screen there, they're all really recording either at 1 millisecond or at 10 milliseconds or at 100 microseconds, so 1/10 of a millisecond. They're all in that sort of range. And all of them, I guess, obviously, if you're going to data log things, you've then got data and you want to export that data. So all of those devices allow you to export data onto another piece of software, so onto a PC or onto a mobile phone, where you can then analyze it further or share it or produce a certificate. The device on the right-hand side, the DHM, you might notice it looks slightly different. So that's a portable hydraulic tester with what we'd call point measurement or log on a key press measurement, where you're not really interested in how long the time is between taking the first point and the second point. Typically, you might be using it to carry out like a volumetric efficiency test of a pump. So maybe the pump's at full flow and at no load. As you progressively load it with the load valve, the pressure goes up and the flow comes down. And for each of those test points, you might just log a point on the tester and save that to memory. And then you end up with 10 or 20 points of data, which are then very handy to produce a certificate. And again, we'll touch on that a bit later on. The last thing perhaps just worth mentioning is, so what are the values that we're recording? And if you look across the bottom there, we've got actual, min, and max. And without getting too into detail in this, the rate that you sample at could be different from the rate that you save the data at or record the data to memory at. So you could be sampling the data 1,000 times a second, but then you might only be saving the data once every second. And in that instance, you can then, especially on the devices, the left-hand 4 devices, it will look at what happened, what was the minimum value over that second, what was the maximum value over that second, and what was the actual value at the end of that second. And it can store those 3 pieces of information. Why would you want to do that? You might ask, well, it allows you to record less data, but still know what's going on in the circuit. So if you had a max value of, let's say, 400 bar and an actual value of 200 bar, then you know that peak happened, that peak pressure happened. You may not know exactly when in that second it happened, but it certainly happened. So again, these are things that we can talk about a bit more as we go through the different examples. Okay, so if we go on to section 2, use cases. What we're going to do is going to go through each of the different 5 products and just explain a bit about how they might be used and how they could be helpful. And to do this, some of you who may have attended some of our webinars in the past know we like to use a company, a story, if you like, around a particular company. This is a fictitious company called Mining and Oilfield Services. Its mission is to always create a safe working environment, be a reliable supplier of choice, and provide innovative solutions. It isn't a real company, but it's perhaps very similar to many companies that we have dealt with. In it, we've got 3 characters. We've got Lauren, who's the CEO of the company, and then we've got Declan, who heads up the design team, and Steve, who is the service manager. And they have a particular challenge. They've got this crushing machine. They've also got a fleet of other machinery around the mining environment. They've got this problem here. They've got continual hydraulic motor failures on this conveyor drive. So Lauren's said to Declan, right, you better check the machine design because this is causing a real problem. The downtime's very expensive on that part of the mine. And said to Steve, you better check the machine operation. So if we look here, this is the conveyor drive. So we've got a top view at the top of the screen and a side view there as well. And we've got the rocks coming off, and an angled screen pushes the oversized rocks off. The rest go into the little hopper at the end. So if we just start that conveyor up, we can see the rocks moving across from left to right. Then a big rock comes along, falls off into the pile. What we know from the maintenance book is that the hydraulic motor requires frequent replacement on this conveyor drive, and that the motor is rated to 280 bar. And we have a trusty glycerine pressure gauge mounted onto the motor. And it shows nothing unusual. There you can see the gauge is around 225 bar. And we know that the rating is of the maximum rating of the motor is 280 bar. So you think, well, there's nothing wrong with that. Sounds about right. Then the oversized rock comes along, pushes it off. The gauge doesn't really move. It's still saying exactly the same pressure. So there's nothing really to indicate what the problem is there. So this is where a data logger can be very useful. So if we introduce the HPM 110, so this is a digital pressure gauge. It's got a sample rate of 10 milliseconds. It can record up to 18,000 points in one test and record up to 10 tests. Plugs in onto any M16x2 test point. You can leave it there and logging up for 24 hours. Ideal really for this particular scenario. Don't have to stand there and watch the gauge the whole time. They can just screw the little data logger in and walk away and come back to it sometime later. It runs off batteries. And as I mentioned before, it also looks at this minimum maximum pressure. So now we'll run the conveyor belt again. This time we've got the pressure gauge mounted on the motor. Here we're looking at what the minimum pressure has been in the last 12 hours that we've been running for. You can see there it's 193 bar. Now looking at the maximum pressure, and we're surprised to see that it says 320 bar. Or beforehand, when we were looking at the analog pressure gauge, it was only 225 bar. We can also, once we've got that data, we can plug a USB cable in, download the data to our computer, and then plot the data against time. What we can see quite clearly there is that we've got a couple of pressure spikes, 299 bar and 320 bar. Really, that's the beauty of the data logger. Let's go back to that screen. Is that if you compare that with the glycerine gauge, which didn't really tell you anything at all, not only can you see the value, but you can see when it occurred, and you can see how frequently it occurred. So that leads very quickly to being able to ascertain that the problem really is around pressure spikes. There is a different device you could have used, so you could move up to the HPM 4000 data logger. Here you could plug a pressure transducer in and a cable. You could have the device a bit further away. You could plug in other sensors as well, maybe 2 or 3 pressure transducers at the same time, or measure flow at the same time. So here we've got the results feeding straight through to a computer, and there we can see that when the rock gets stuck, you can see that the pressure spikes. And Declan knows from the hydraulic circuit diagram that you can see on the left there that there is a relief valve mounted just after the pump. But also realizes that this conveyor belt is an awful long way away from where the pump is. So the motor is a long way away from where the relief valve is. So he's realized the problem's caused by pressure spikes when rocks get jammed under the screen. You can see that from the data on the data logger. And Declan's gone, okay, we'll fit a direct acting cross-line relief valve very well close to the motor. So that's what they've done there. They've set that 10 bar below the motor maximum pressure just to protect it. So that little example there shows you really the power of what the data logger can do compared with just a standard glycerine gauge. And also in this particular example, Lauren's very happy because you can see that they've now solved the problem with the conveyor belt and addressed the downtime issue. So if we look a bit more at the level 2 product there, so the next largest device in the range, the HPM 4000. So as we mentioned before, as well as monitoring pressure, can also monitor other variables such as flow, temperature. It could display peak pressure. It can also carry out basic calculations. So we could do differential pressure calculations, power calculations. And there's no real link between the size of the device and the size of what you're measuring. So that little handheld device could be used with the largest flow measurement and load valve that we have in our range. So this here is a 1500 litre turbine flow meter linked with a load valve. That could be used just as a much smaller flow meter could be used with this handheld readout. Also mount a pressure transducer on there. So now we've got flow and pressure. We've also got temperature inside that pressure transducer, as we could have inside the flow meter. And so we can feed all those readings through onto the readout, and you can see them displayed on the screen there. We're to look now as we load the system, we can see that the flow is coming down as the pressure goes up. So as the pump has to work more. And we've also got a calculation on the bottom there for the power. So there it shows that it's generating 370 kilowatts of power. It was a very large system. And you can also see the impact there on the heat as there's such a large pressure drop across that. So some of the other use cases, so could be used, if we think back to about the maintenance types, think about whether it's reactive or whether it's preventive maintenance. So here it could be, or proactive maintenance, it could be for setting up pre-dispatch inspection, or it could be for fault finding. Once you've got that data, you can then extract it via USB cable. So if we look at how we connect the sensors to the data loggers, there's three options really. So the first example here is we've got analog sensors, one sensor, one cable, one connection. So you can see here on the HPM 4000 for analog 4020, we've got two sensors and two cables. For WebTech uses something called the sensor recognition protocol. It's their own protocol which enables you to plug those sensors in, and it recognizes what the range and type of that sensor is. So it recognizes the difference between flow and pressure and temperature. So it knows what units of measure to display. It also recognizes whether it's a 60 bar pressure transducer or a 400 bar pressure transducer, and ranges it accordingly. What does that mean for the user? It means you don't have to do any setup. Equally, you could use CAN sensors. So these are based on the CAN bus communication protocol. Again, this is a WebTech flavor of that. So again, it enables you to automatically scale and recognize sensors. So when you plug them in, it knows different types of sensors. It knows their serial number. It knows what range they are. Also gives you the advantage of quick setup. CAN is slightly different. It runs on a bus. So they are all daisy chained one after the other. So you have one cable going into the device and then connecting via those Y connectors into the different sensors. The advantage of CAN is that we can send multiple signals along one cable. Also, we can have very long cables without seeing any deterioration in the quality of the signal. Where if you're running analog sensors, you would probably typically try and keep the cable lengths down to sort of 10 or 15 meters maximum. Here, if you have to run longer cables, it's not a problem. So now we'll step up into the next size of device. This is the HPM 5000, bit bigger, 4.3-inch screen. Here we can measure flows, pressures, temperatures, speeds via that CAN port. And we've also got the ability to put in AUX, so that AUX is auxiliary sensors. We can put in a couple of those, either 0 or 4 to 20 milliamp or -10 to +10 volts. So if you have your own sensors that you already have before you buy any of this kit, you can feed those in as well. And then you've got a USB connection there for charging it and for sending data out to your computer. This is the mid-range data logger. So it's got a bigger screen. It can also do calculation channels. You've got graphical display and streaming, and also touch screen operation. There you can see that example of the values being shown on the screen. So one of the features on the HPM 5000, remember, as you go up in size in the devices, you get a few more features and different types of data logging. So if we think back to that conveyor belt example, one of the things you could have done there was set a trigger. So say, well, if the pressure goes over 250 bar, let's start data logging then, rather than data logging continuously. Pressure greater than 280 bar in this example. That gives you a spike and then everything that comes afterwards. One of the clever features within a data logger is you can run a ring buffer, so it will continuously monitor what's happening, and then you will have the data that happened before the trigger happened. So that then enables you to get a picture of what happened running up to that pressure spike as well. You can also run auto repeat on these devices. So you could say, right, I want you to capture data every millisecond for 10 seconds. 5 of those seconds happen beforehand, and then I want you to repeat the test every time you get that trigger. Connect the device up, leave it there for 24 hours, and then come back and analyze the data afterwards. So real benefits to being able to do automated data logging. So here's another use case around the HPM 5000, a very large demolition excavator. Again, we're going back to the 1500 litre tester, so flow meter and load valve. You can see, open up the device and plug in the flows, feed in pressure, flow and temperature, and there you can do monitor the multiple channels at once. Could be that you're doing this for pre-dispatch inspection. Equally, it could be there for doing a pump test. Had an example recently where there was some uncertainty by the operator as to whether there was an issue with the attachment or there was an issue with the pumps on the machine. If you want to work out where the problem lies, they connected up a device like this, tested the output from the pumps, could data log it and see very clearly, yeah, the problem is that the pumps aren't delivering the correct flow, not that the attachment isn't working correctly. And actually that seems to be a common theme when we talk to customers. It's often where not quite sure where the problem is inside a more complex hydraulic circuit, particularly where flow is being supplied to an other function. If something's not working, there can be a bit of finger pointing. Go in there and test each device independently, and you can work out where the problem really is. So the next level up, HPM 7000, sort of supersized version of the 5000, monitoring of multiple parameters in complex systems. This now got a 7-inch display. You've got 48 channels over CAN, over 2 CAN buses. You've got 4 auxiliary channels, and you've also got 2 slots on the side. You can't see it from this angle, but they're on the top. you can feed in two different modules yourself, which either allow you to have more analog channels or to have a CAN J1939 module, so that you could then read what's going around the CAN bus on a machine. Fully featured data logger can do an awful lot with this, maybe too much for some applications, but certainly where you've got more sensors, more complex hydraulics, maybe where you're doing R&D or you're doing sort of complex warranty testing, it's ideal. So this is a better view. Here you can see the modules in the top. At the back, they're connected in with the blue lines. They're the analog sensors coming in. And then at the bottom, you can see the green lines going into the CAN network. As you can see there, multiple sensors going in. It could be a lot more than that if required. One of the advantages of this particular device is it can also be permanently mounted. It can be used for test benches. It could also be used for pre-dispatch inspection, certification, R&D, etc. Prototype machines. We've got a few customers where R&D department are putting a machine through its steps at prototype stage and wanting to measure pretty much everything that they can and look for any anomalies, look for what the maximums are on flows and pressures and temperatures. You could feed in on the auxiliary channel. You could feed in a linear transducer for cylinder position, or an angle transducer, or a torque meter, contamination monitor. Feed all that information in so that afterwards you've got a really complete picture of the operation of the hydraulics. And for example, from a fault finding issue, there you've got all of those, all that timber hanging off the front of that boom arm. There might be a high inertia load, and you want to understand what impact that's having on the hydraulics. You could do that with the help of those visual traces against time that you can see on the screen there. So one of the things I did mention, here's a test stand application. So I think it's a really neat application here for what is supposedly a portable data logger, but you can use it very sensibly as a test stand solution. Here's an example of an old valve test stand. So the test stand's probably been around 30 years, would have been decked out with glycerine gauges and sort of ammeter style displays. And then it's had a complete overhaul from an instrumentation point of view. So the same HPM 7000 you can see on the left-hand side of the screen there. A laser out. So we've got the HPM 7000 mounted inside this plastic housing here. So it's just kept away from splashed with oil. Hasn't got a problem with that. It is highly IP rated, but just keeps it a bit tidier. On the right hand side here, you can see the various flow meters and pressure transducers that are mounted onto the power pack. And then with the help of VNC and a network cable out of the back of here, we've fed this into another computer. And then we've got complete duplication of the display. So everything that's displayed here is displayed up here. And we've also got complete control with a separate mouse and keyboard. Just allows you to really run the whole data logger by remote control. And I know for some customers, they don't want to necessarily have something that's tied up permanently on a test stand. You could still open that box, disconnect the data logger, and then use it for an in-field or out in the field data logging sort of fault finding application, and then bring it back and use it on the test stand again. So a very flexible solution for both permanent installation and for mobile use. And behind all of those HPM range, there's the HPM.com software. It's free to use software. It's downloadable off our website, and you can then plot the data that's been captured on those data loggers and use that to analyze the data a bit further. Okay, so last and by no means least, the other type of data logger is where we've taken a portable hydraulic tester, which you typically use for testing pump performance, for measuring flow, pressure and temperature. We've got a load valve built in there, and we might just want to record what's on the screen as and when we test at different flows and pressures. And as you can see in that example there, there's a mobile phone in the top right-hand corner because we've got an app, the QuickCert app, which comes alongside it. So if we were to open up this mobile crusher and then to carry out a pump test, here you can see the data logger, the DHM with data logging functionality mounted after the pump and after the relief valve in this particular example. As we turn the load valve handle, we increase the pressure, the flow might then start to drop off. How much it drops off dictates really the efficiency of the pump and how worn it is. This particular example, you might want to be careful as to whether the oil is disappearing over the relief valve or not, and you could always move the tester to a different location. The point is you could log all of that data on a key press, and then you can share that data very easily via Bluetooth with the free-to-use app that can be on an iPhone or an Android phone. And so you can see there the example of the data plotted across the screen, and you can also see that you can produce a certificate straight from that and share that with other people. So while this is a different form of data logging, it's not data logging every millisecond and producing thousands of points. It has its place for just simple certificate creation to say, what did you see on the screen? And there it is with 100% data integrity, producing a certificate. We see that out in use in the field. One of the other things that the advantage of being able to store and share data is that you can also then duplicate the display. And so in this particular example, here we've got a Bluetooth connection between the tester and the app. It could be horrible weather outside, and the service engineer could be sitting in the comfort of their car and seeing what's happening on the screen of the tester in real time. So it can do two different things. That particular application, it can review data that's already been logged on the tester, or it can give you a live view of what's on the screen. Okay, I appreciate I've rushed through 5 different use cases there. Hopefully you've managed to follow that okay. The next section of section 3 is I'm going to hand over to my colleague Steve. He's just going to show you briefly on our website how you can find out further information, download bulletins, etc., and get in touch if you'd like to. So Steve, are you ready for me to hand over to you?
I am indeed.
Okay, all right. So I'll leave you to take over then, Steve.
Okay. Right, can everybody see my screen now?
Yeah, we can see that, Steve.
Okay, so thank you, Martin. As Martin said, I'm going to give you a brief overview of our website, where to find some useful information. So
Steve, sorry to interrupt, Steve. You're not quite full screen at the moment. Can you just, I'm not seeing.
Can I just stop a minute then? Just a minute. Because it should be. Right, let's try now. Is that any better?
I don't know about anybody else. I've got a band across the top.
It's cutting off the top half of the screen.
Cutting off the top of it.
Right.
But worked perfectly when we tested it.
Yes, it did.
As it always does.
Yeah.
Live demos are wonderful.
Yeah. And now?
There you go. There we go.
Right.
It's much easier to see now.
Yeah. Right. So if we come across the top and go down to the tab where it says products, first of all, if we start off with the hydraulic data loggers, which is what Martin's been talking about, and click on there, we will find you'll find the data loggers all appear. You'll also find a comparison chart. So if you was to click on that, that gives you some very useful information. I'm not going to go through it now because it will show up so small for you guys. You won't be able to read it. Let's go back. So if we if we were to look at some of the products, we look at the HPM 5000 and click on that. That then shows you some information about the product itself. And if we scroll down, as with most of our products, you can request a 3D model if you wanted one. We come down, we have the literature, we have manuals, case studies, and software within that tester. Okay, and then coming again across the top, we go across to education. This is going to give you some useful information. So first of all, we've got the practical hydraulic system maintenance book, which was written by Steve Skinner and Martin Cuthbert. Some very useful information in there. Scrolling down, we have hydraulic fault finding, which is going to give you some information on hydraulic cylinder testing circuits, pump testing. So basically there's some videos there. And then we've got other useful information, technical reports, etc., going down there. If we then come to downloads, click on that. So now we have the sales bulletins, technical bulletins, instruction cards, product overviews, all that sort of stuff. And if we click down here, we've got some very useful videos. You click on the YouTube one here. There's a lot of information on data loggers. So we can see HPM data loggers, part 1, 2, 3, and 4. And then scrolling down, you've got some useful information on the HPM 7000. And then last but not least, we've got contacts. So this is how to find a distributor. There are a number of ways that you could do this. You could put in the country. You could also scroll up. And forgive me, any of the distributors that are online that I haven't chosen you, but let's just pick this one. So I've picked one in Italy, so it's come up with Oli Mechanica, and that gives you the contact details, email address, and web address, etc. Likewise, what you could have done is you could have scrolled in and out, or you could have moved it across and just done it that way. So if I then click on this one here, it gives me HTM hydraulics in India. So I think that's about it for now. So if I can pass back to Martin.
Okay, thank you, Steve. Okay, so we've covered the 3 sections of the webinar: a bit of introduction and background, the 5 use cases, and then where you can find further information. Please go to our website, www.webtech.com. As Steve mentioned, please feel free to contact your local WebTech distributor. If there's a particularly difficult use case that you have, complex test stand or something, you need some help specifying a product, feel free to contact us on sales@uk.webtech.com, and we're happy to organize a little Teams call and talk to anybody. That really covers everything that we wanted to cover in this particular webinar. If you want to find out about future webinars, then don't forget to subscribe to our mailing list or follow us on LinkedIn. I think that covers it. Sam, is there anything else that we need to cover at the end of presentation?
No, I don't think so. No, thanks to both of you for that. I guess I can finish off in a minute, but unless there's any questions that anyone's got, I haven't seen any in the chat yet. But if you have a question, then by all means ask it now. If not, get in touch as Martin has just explained. I guess for me, I'll follow up. So in the next sort of half an hour to an hour when this processes, you'll get an email with a link to watch. For anyone that's attended or hasn't attended, you can watch it afterwards. Excuse me. I will send an email around later today, hopefully with some links to some case studies, to some parts on the site that we think are relevant and interesting I will put a link. This will go up on YouTube as well, so I will share a link to that. If there's anyone that you'd like to share it with that didn't sign up, then you can use that link to share with them. I will put some other links to maybe the comparison chart that Steve mentioned. I'll put that into an email. And I think what I'll do is also because one of the best things is feedback for us. So if you've got any ideas or any suggestions of things you'd like to see for future webinars, then please, reply back to me and let us know. We can put them on a list. We have a working list of what we would like to talk about, but it's always good to have external ideas for things. So any feedback is greatly appreciated. There is a question there. It's, what is it? Any instrument can detect hydraulic internal leakage, is what the question says. I'm not sure if that means can the data logger detect hydraulic internal leakage? I'm not sure if that's what that question means.
I've got some thoughts on that. Steve, do you want to take that one?
Yeah, I mean, my thoughts are yes, it can, but you would need to be able to measure it before and afterwards. As long as you know what the inlet flow is, and you're measuring it afterwards, you would be able to determine how much leakage there is. It's just knowing where to put it in the circuit.
Okay, thank you. Okay, well, I think that's it, and yeah, I think we'll leave it there for everyone. Thanks for joining us. Hope to see you on another one, and yeah, enjoy the rest of your day or evening. So yeah, thanks everyone.
Thank you.
Bye-bye.
Thank you. Take care.
Bye.
Thanks. Nice to see you.
Recording.